So yesterday we talked about solving a system of equations by substitution. Now there's other ways of doing that, solving the systems of equations that is. And today we're going to talk about elimination of a variable by adding or subtracting. Now in this situation, we're going to find a constant in front of the same variable that's going to be exactly the same. In this case, I have 3x and negative 3x. So I have a variable here, x. I have the constant in front of it exactly the same. So I can solve this by just adding these two equations together. Now what happens when I add the two equations together? Well, the negative 3x plus the 3x is going to go away and gives me a 0. So I'm going to look at a 4y minus 6y. That's going to be a negative 2y. And a 12 plus 18, which is going to be a 30. Okay, because we added these two together, and we added these two together because these two variables were exactly the same. Right? Now, once I have that negative 2y is equal to 30, I can divide both sides by 2 and I come up with y is equal to a negative 15. Right? Now, if I put a negative 15 into my variables, okay, I come up with a 3x plus 4 times negative 15 is equal to 12. So that's going to be a negative 3x, and 4 times the negative 15 is going to be a minus 60 is equal to 12. Probably it's a positive 12. If I add 60 to both sides, I'm going to come up with a negative 3x is equal to 72. And if I divide both sides by a negative 3, I'm going to end up with x is equal to a negative 24. All right, so I'm multiplying, dividing both sides by a negative 3 here. Right, now on this side, I come up with a 3x. Negative 6 times a negative 15 is going to be a positive 90 is equal to a positive 18. If I subtract 90 from both sides, I'm going to come up with a 3x is equal to 72, negative 72 because it's a negative 90 plus a positive 18. And if I divide by 3, I'm going to come up with x is equal to a negative 24. So my point of intersection between these two lines is going to be the point negative 24, and y is going to equal a negative 15. That is my point of intersection. And we got that point through adding these two equations together, eliminating a variable. Right? Now, in this case, I have a 4y plus 3x is equal to 22, and a 3x minus 4y is equal to 14. It would behoove us to get both all the x's and all the y's and all the numbers above each other. So I'm going to change the top equation to go to 3x plus 4y is equal to 22. And I'm going to change the bottom equation, leave it the way it is, and I got 3x minus 4y is equal to 14. Now again, notice I have a positive 4y and a negative 4y. I can subtract those from each other. And when I do that, in this case, I'm going to add those to each other. In this case, I get 3x plus 3x, which is going to be a 6x. I'm going to get 4y minus 4y. That's going to give me a 0. And I'm going to get a 22 plus 14, and that's going to be a 36. So now if I divide both sides by 6, I come up with an x is equal to 6. So my x value is equal to 6. What's my y value when x is equal to 6? Well, let's go back and put this into my equation. I'm going to get 4y plus 3 times 6 is equal to 22. That means that 4y plus 18 is equal to 22. I subtract 18 from both sides. I come up with a 4y is equal to 4. Divide by 4, I get y is equal to 1. What if I had chosen this equation instead of the one I just did? Then I have 3 times 6 minus 4y is equal to 14. And that's going to be an 18 minus 4y is equal to 14. Now if I subtract 18 from both sides, I get a negative 4y is equal to a negative 4. And if I divide by a negative 4, I come up with a y is equal to 1. So my point of intersection in this case then is going to be the point 6, 1. That's the point where they're both going to go through. Now, if I get a number here and I just choose to put it into one of these equations, or one of these equations to see what the value for y is, that works. If I've done everything correctly here, it's going to be okay. But if I put that 6 into my second equation, I come with the second value, the same value here down here for y, then I know I've done this whole process correctly. All right, if I look at this problem over here, if we get the things above each other, I get 2t plus 5r is equal to 6. And let's do the other one, which is going to be a 2t plus 9r is equal to 22. All right. Now notice I have a 2t and a 2t here, but they're not going to add together and give me a 0. All right. But if I take 2t minus 2t, that does work. So we're going to subtract this bottom one from the top one. But if I subtract it, I got to subtract everything in here. So this is going to become a plus a negative 2t, a negative 9r, and a negative 22. So when I add these together, I'm going to come up with a 0. But this positive 9r now becomes a negative 9r. So I'm going to come up with a negative 9r plus 5r, negative 4r. And I'm going to have a negative 22 plus 6, which is going to give me a negative 16. If I divide both sides by a negative 4, I come up with r is equal to 4. Okay. Well, in this case, I'm going to come up with a 2t plus 5 times 4, which is going to be a 20, r is equal to 4, is equal to 6. So that means that 2t is equal to, subtracting 20 from both sides, a negative 14. I believe that's what that's going to be, which means t is going to equal a negative 7. If I were to try my other equation here, let me give myself some room here. Now if I put 4 in for 2t in this, 4 in for r in the second equation, I'm going to come up with a 36 plus 2t, because 4 times 9 is 36, is equal to 22. Again, subtracting 36 from both sides, I get 2t is equal to a negative 14. And just like before, if I divide by 2, t is equal to negative 7. So my point of intersection, since r comes before t, we're going to form rt, would be negative 4, negative 7. All right. So that's the idea of solving systems of equation by eliminating the variable through addition and subtraction. Hope you have some questions.